you heard the name of the topic. So it's basically two buzzwords walking into a bar and starting a fight. And we're all collateral damage, so I'm sorry. But I'll start out pretty slow. First of all, this is a DevOps standpoint, and if you read my bio, you kind of see that I'm not a DevOps engineer. Well, not anymore. I was, and at my heart, at my core, I will always be a DevOps engineer. But my transition into being a developer advocate was because I've been teaching people to code for almost 3 years now. And that's pretty much what I want to do today. I want to teach you something new. I want to teach you something you can use tomorrow in your own projects. And first of all, the main thing is that I want to show you how to manage your own containers versus letting serverless do it for you. And that's a very cool thing. The main 4 things I want you to understand after this talk is, first of all, how to get optimal scalability and performance, whilst also having the least amount of maintenance in your application and spending the least amount of money, because if you're an entrepreneur, you're going to want to know that. Just to start with a short agenda, so you know what we'll be talking about for the next 20 minutes. The 3 main things we will cover will be what the 2 technologies are, meaning what are containers, what's serverless, all those buzzwords. So nobody's going to leave this room confused anymore. We will understand what this is. Apart from that, we will also cover the pros and cons, meaning I want you to know when to use what and which use case. Finally, we will also cover a deployment process, because I want you to know what it's like to deploy a set of containers into a Kubernetes cluster, another buzzword. We won't go into detail about everything, so you can just calm down. Nobody's going to get scared. It's going to be fine. And then we will move on to doing the same thing, but with a serverless environment. You ready? I can see everybody in the front row really happy. Yay! But let's start slow. Let's start slow. First of all, what are containers? Hopefully, we have a couple of DevOps engineers in the crowd. Feel free. Let me see you. Awesome, nobody. I guess everybody's a front-end engineer, though. So, can I see the front-end engineers? Like who's here, though? Like, what are you doing? Go get. Okay, so let's start slow. We can start slow. First of all, I want to mention that a container is basically an isolated stateless environment. That means that it is like a container. Nothing can get in and nothing can get out unless we let it. And that's all there is to it. Another amazing thing with containers is that it abstracts away our infrastructure, meaning that the operating system of our hosts doesn't really matter. Everything that matters is what we put into the container. So we can shift our containers between hosts and it'll be the same thing. Because I'm a strange human being, I like starting with the bad things first, bad news, good news type of deal. So I'll start with the bad things with containers first, so you get the perspective. The first thing is that it's a very steep learning curve. If you know anybody, or if you have started the process of learning about containers, you know there's a lot to learn, and it's very hard. Apart from that, it kind of ties into the thing that it's very hard to deploy as well, because the process you need to go through to get something deployed, it's huge. And it's not easy at all. Lastly, because we want scalable and performant applications, we don't have that by default with containers. We need to learn that step as well. We need to learn the process of adding auto-scaling to our applications. And that's an overhead if you're new to this, or if, like you here, are not DevOps engineers, so it's going to be fun. Moving on to the pros here, the main upside of using containers is definitely that you have full control. Because it is hard to learn, you also get the control, because you're the one doing everything. Meaning you can theoretically have infinite scalability. If you know what you're doing, of course, because Yeah, let's be real. Apart from that, it's incredibly easy to have a quality set of debugging and monitoring tools because the ecosystem is so good and so mature, you can pretty much just grab a finished, done tool and like a Lego brick, add it to your cluster. And that's very powerful. And I think that the last pro or the last great thing about containers is the collaboration, how easy it is. I think that everybody in this room has had one of those developers in the team that says it worked on my machine and then broke production. I can see everybody just silently, yes, that was me, but I understand, I've done it myself. You don't have that with containers. Because everybody has the same environment, no matter which operating system they have. Is it Mac, Linux, Windows, whatever? Okay, we have the pros and cons done. Let's think about the use cases a bit. Of course, like any application, using microservices or creating microservices and web APIs is a given. You can build this with anything, on anything, whatever. So, of course, you can do the same with containers. But why containers are good is because you can migrate over your existing monoliths into a container and then just gradually pull things out and create microservices from it. And when you think about it, that makes it very easy to migrate over legacy systems. Another cool thing is that you should generally try to use up all the resources you have inside your containers or the actual CPU resources on your host because long-running processes are amazing to run in containers. You're paying for the host all the time, use it all the time. There's no point in having it idle. So that's why I think it's also very cool to use containers as hosts for data science and machine learning, all those new cool AI, blockchain type deal things that nobody actually knows about but still use for some reason. Okay, that's enough about that. I think we're ready to understand what serverless is now. First of all, I know the name is stupid. Everybody thinks the name is stupid. And we have all those internet trolls on Reddit saying it still uses servers. Well, yes, it does. I mean, it's not going to run on air or something. So, but let's break it down. First of all, to keep this presentation short, I want to say that I'll only be mentioning function as a service or the compute service that's called function as a service. And why is that? Because function as a service is essentially just an event-based system for running code. So you have an event that triggers some code, it executes, and returns a value. And you forget about it. You don't care. And that's why it's called serverless, because I don't care about the servers. I don't care about it. I don't want to know what it does. I don't want to know what the infrastructure does. I just want my code to execute and to return a value. So please, if you have anybody here in the audience that's like, oh, serverless is a stupid name, okay, we get it. It's stupid because of this, because we don't care about the code. Okay, let's move on. The bad parts, though, there are a few. And the main bad part I can think of is that we have defined limits. What does that mean? It means that we basically have a defined set of, well, memory limits and CPU limits and time limits we can allocate to our functions, meaning that a function can only have a set of performance indicators in it. And that's pretty dangerous because it can lead to something like this. It can lead to latency. And we all know that having overhead and latency, it's not really that good. So we have to watch out for that. But apart from those two, I think the most dangerous is having bad observability, because we're already used to having the tools you can add to your cluster and the tools that are built in. We don't have it here. And that's why I pretty much look like this every time I have to debug my serverless applications. But moving on to the pros, I think the pros outweigh the cons by a mile. That's because it's so low maintenance. It scales by itself, it just works. It's pretty much like having a cactus. You just have it and you forget about it. But, I mean, I like that because I'm lazy. But then again, what's cool is that you only pay for when it's running. So if you have a function that's running for 200 milliseconds, you pay for that, and then when it shuts down, you forget about it. That's pretty good if, again, you're an entrepreneur and you care about that stuff. But I think the main power of this is because it's easy to deploy. So you can pretty much be a dog that has no idea about anything and still get it running in production. Or a front-end engineer, but yeah. Well, but we have a code of conduct, so I'm going to shut up now. But let's see the use cases. And after these use cases, we're going to jump into some examples to make that more interesting. The main thing is that, of course, microservices and web APIs are the same as with containers and with like everything else, so that's okay. But what I think is important to note that using serverless functions for processing data streams and images and whatever is amazing, because that's what you want to do. You want to trigger and forget. You want it to run, you want it to do something, save some data, send something, and you just forget about it. That's the power of this, because you don't need to manage those things. Of course, you have to think about the fact that they are time limited, so you can do this for short running processes, for maybe image optimizations or APIs or whatever that's under 5 minutes. If it's over 5 minutes, think about containers. And finally, an ideal use case I use all the time are periodic processes and cron jobs. Maybe an upload of an image will trigger something, or every morning at 9 a.m. I want something to get done. Again, because I don't want to care about those things. Okay, so this was pretty tiring. Now we can move on to do some examples. I want you to understand the process of deploying something like this in the real world, both a containerized application and a serverless application. So let's start with the containerized one first. Just to be real, this is the easiest way to get the cluster up and running on AWS. It's horrible, and this is the shortest and easiest way. So imagine if you don't know what you're doing. You're going to be stuck, you're going to be lost, and you're going to spend weeks on learning what the hell is going on. But once you have that done, it gets easier. First of all, you need to install Docker. Everybody knows about Docker. That's what creates your containers. Once you have that installed, you can be a developer again. You can write your code, write everything you need, and then you need to create something called a Docker file. Here's where you configure the container itself, or the image, how you want it to look. And then you have to use that file to actually build your image. And as you can see, this process is kind of taking its toll, because I'm already winded and I should go to the gym more often. But once that's done, you have to push the image to a repository, meaning it's just the same thing as a Git repository, but you don't host your code there, you host your images there. And again, this is just half the process. Once you have your image on that repository, you have to pull it to your cluster, meaning you have to install another tool to have the interaction with your cluster. And then, of course, you have to write another set of amazingly long files to write your configuration for your container, for your cluster, because again, you're managing everything and it's horribly, horribly hard. So it's basically, this is my face when I did it the first time. I was a fat kid back then. And then, when you have all the files, then you have to apply the actual files towards your cluster. You have to tell your cluster, okay, create all this thing, all the containers and the pods and all those words, create it all. And then you have a running application. I don't know if anybody was so kind in the audience to actually count all the steps. I did, 8 steps in total. And doing that every day is horrible, so you'll just most likely write a CI/CD pipeline. How many people know what a CI/CD pipeline? Yes. You see, DevOps. But, okay, let's wrap up the container part. Now, I want to show you the serverless application, what it looks like to deploy the same application, but to a serverless environment. Count with me now, okay? First, we install a framework that's basically a tool, a CLI tool for deploying and developing your application. Then, You're a developer again. You write your code, do whatever developers do, configure the event triggers, meaning I want one HTTP event to trigger one function. And then, guess what? You run one command. One. And that's it. You have everything running in the cloud. You have your application running in the cloud. And tell me this. How hard would it be to write a CI/CD pipeline for this? It's like, you remember the dog picture? Yeah. That's how hard it is. Okay, so to wrap it up, I just want to finish with a verdict so you can just sum up everything I spoke about during the last 20 minutes. The container side. If you want to have control, use a container. If you want to have flexibility, if you know what you're doing, use a container. If you have a legacy code base and you need to migrate it over to microservices or to whatever, start with containers. But if you want to iterate fast, if you want to have fast deployment, fast development, if you want to have auto-scaling built in, if you want to have relatively low costs, use serverless. It does make sense. And to wrap it up, I just want to say a quote by a person I respect eminently. I don't really have to say his name because you probably already know him. And he said that we should build serverless first, and then if we need to, migrate over to containers. And that's all for me today. Glad you had me.
Plenty of time for questions. Who has questions, raise your hand.
Hi, great talk. First of all, I wanted to say that you can't just buy a cactus and leave it alone, it will die. The second thing is...
That's why they died.
Second thing, so serverless, when you said about the Lambda functions or the function as a service, as far as I know, there are only a limited set of providers and they provide only a limited set of languages. This is usually my main reason why I go for containers. Do you perhaps know any workarounds or any services that provide perhaps more language agnostic implementations of functions as a service?
Yeah, sure. First of all, I've worked with AWS for the majority. It is the largest provider and has pretty much everything you need. But regarding AWS Lambda, that is the FAS service that they have. Regarding the languages, they support pretty much everything except for Ruby. So I guess that's the reason why you're not using it. But that's true. But if you still want to use Ruby, I think it's super fine if you use something called Fargate. That's basically the same thing as Lambda is, but for containers. So you can build a container, put it into Fargate, and Fargate will trigger it based on an event you specify. So it's quite literally Lambda, but for containers.
More questions?
I have a question, but also an observation. Serverless as a framework has some drawbacks. So we in the firm tried it out and moved to managing our serverless functions only via Terraform and CI tools. And the question is, what do you think about recent projects? There are several that use and build serverless on FAS on top of Kubernetes as a solution to have, for example, the issue with the languages removed.
First of all, I think both OpenFAS and FN project that are built as serverless solutions on top of Kubernetes are amazing. They're great projects. They're both open source. The leaders of the communities are great, like great engineers as in community leaders as well. So using any of those is, I'd happily use it. And what was the second part of the question?
What do you think about?
Oh yeah,
Are they production ready?
yeah, definitely use it. I was at a talk not so long ago this summer where a guy spoke about using FN project he moved from Google Cloud and the Google Cloud functions over to FN project, and he was super fine. So, but I would argue against using Google Cloud functions because they're not so good. but Azure and AWS Lambda have nailed it. They're amazing.
More questions? Oh.
I keep breathing into this thing.
Hi. So I think that vendor agnostic solutions are always better, so and open source solutions also. So in terms of just comparing, getting back to the thing about Google Cloud Functions versus AWS Lambda, I heard completely opposite experiences. Like you can connect to your own real SQL database without delay on Google Cloud Functions, and for AWS Lambda you have really big limitations on there. And also the way you deploy things by using their like low-level tools is much more convenient or ergonomic on Google Cloud Functions. So what's your take on this in more details?
Did the guy work at Google that told you that? Or okay. No, no jokes. Generally, Google Cloud is amazing for the Kubernetes support they have. Definitely. The function support they have, not so much, sadly. Regarding Lambda, Lambda has 25-something integrations for event triggers, and they have 2 different database supports that are serverless databases, meaning you don't have to think about connection pooling, you don't have to think about connections at all. You just have a connection to your serverless database that will scale up and down. I mean, serverless database, Aurora. Do you know Aurora, RDS? It's the serverless RDS. Just check out serverless RDS Aurora and it will throw it out. Like it was, I think 2 months ago they launched it, 3 months ago. So it's relatively new. Of course, you have DynamoDB as well on AWS. That's also, but that's a NoSQL database that also serverlessly scales automatically. It's not that good. RDS is much better. Aurora is amazing. DynamoDB not so much, but you can still use it. So it's up to you to choose what you want. But if you still want to use a default standard database and then worry about the connection pooling yourself, you can do that. That's super fine. If you know what you're doing, of course, you can set up a separate server that only handles the connection pooling. I know Java, the Oracle, they did something regarding making that automatic a couple of months ago as well. So I'll find the link and I'll send it to you.
Hi. So I guess my question is, how locked in am I with Amazon if I decide to use AWS Lambda? Like, if I have a Docker image of a project, I can just like run it on Google Cloud and Amazon on my own server. But if I have a project that's decidedly using AWS Lambda, if Amazon dies tomorrow, what am I to do?
The short answer is yes, you're screwed. But the long answer is, are you using AWS right now? So, are you ever planning on migrating away? Maybe. But how do you often migrate stuff from cloud to cloud? That's the answer. The thing is that, okay, vendor lock-in is a thing, but it's only a problem if you ever plan on doing a multi-cloud setup, or if your client is retarded and like let's move to Azure. But I mean, of course, it's a problem, but it's not that big of a problem that you have to think about. I mean, it's a bridge, but the bridge is far away. So.
Plus, I'm not sure Amazon is going to go out of business anytime soon, right?
Yeah, I mean, I may doubt it, but maybe.
We'll see. Thank you again for a wonderful talk. Let's give them a round of applause.